Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly challenge. Third question, total cost to hire key workers. So first let us read this question, then about the constraint, and then we will be going ahead with the intuition for the same. And finally the coding and time complexity as well. Now here we are given a zero index integer array cost, where cost of I is the cost of hiring the ads worker. You are also given two integers k and candidates. We want to hire exactly k workers according to the following rules. So the first rule here is that you will run k sessions and hire exactly one worker in each session. In each hiring session, choose the worker with the lowest cost from either the first candidate's worker or the last candidate worker. So the thing is that there would be k session run, and then after that means in those case sessions, the thing would be that the candidates which is being given to us, right? So either we are required to take our answer from the first candidate set or the last candidate set. So that is the thing which we are going to do here. So we have explained this thing that, for example, if cost is equal to this much, right, means cost share is like this, and candidates we can choose is two. Then in the first hiring session, we will choose fourth worker because they have the lowest cost. Means from the first two and the last two, this fourth one, that is this one, is the lowest one, right? So we will be choosing this. So that's they want to say. And then here cost was this and candidates was this. So K would be 2. That's why there are two hiring sessions. So in the second hiring session, we will choose first worker because they have the lowest cost as fourth worker, but they have smallest index. So here first two and last two. So we are choosing this first candidate, and because first and the second, third, fourth both are equal, right? So how we are choosing the element is by choosing that element which is at the lowest index. So here 1 is the lowest index, right? So that's why we are choosing this one and discarding this one. So that's the thing. Basically here choosing and discarding simply refers to the fact that when we choose that element, so we completely pick that out from the candidates, means candidate, whatever we take it. So we pick that out, and then according to that, indexing is being changed for other elements as well. So that's why we are required to pick up that element which has the lowest index. Now, please note that indexing may be changed in the process. If there are fewer than candidate workers remaining, choose the worker with the lowest cost among them. Break the tie by the smallest index. A worker can only be chosen once. So that is also another thing which will be fulfilled by eliminating that candidate which we have already chosen. And we are required to return the total cost to hire exactly K workers. And that total cost would be directly on the basis of whatever candidates we have chosen. So that's the thing. Here, let us see the total cost which they are depicting is here 2 is the total cost, and how 2. So in the first hiring round, the lowest cost is 2, right? And when we break the tie by smallest index, which is 3, the total cost is equal to 0 plus 2. Means whatever lowest out of them we are choosing, that is the one. In second hiring round, we choose the worker from this remaining, and now as the candidate was 4, so first 4 and the last 4, out of them the lowest cost is again the 2, but now the index is 4. So now the total cost becomes this 2, which is the new 2, and the previous 2 which was already there. So 2 plus 2 equals to 4. And now the total cost becomes 4. So now in the third hiring round, we check for another these 4 candidates and then these 3 candidates, because here we are already choosing the same, right? So now out of all of them, we figure out that lowest cost is 7, index 3. The total cost becomes 4 plus 7, that is 11. And notice that the worker with index 3 was the common in first and the last 4 worker. So according to that, we are required to have our algorithm in such a manner that wherever there is something common, it could also be handled easily. So now as per that only, our total cost is 11. So this was the thing. And here we can see the constraints are like 10 to the power of 5. So if we go ahead with some n square solution, then it would give us TLE, but n log n solution would work fine here. And each element can go up to 10 to the power of 5. Okay. And the candidates and cost length, basically our kn candidates would be lesser than our cost length. So that's for sure. So that because if candidate length is basically means candidate is basically greater than our cost length, then how we will be choosing candidates when we are not having the availability of that much candidates, right? So that's why this is how constraints are being given to us, and thus we are not required to handle that edge case. Then candidate is basically greater than cost length. So this was the thing. Now let us go ahead about the intuition part for the same. So here you can clearly see how they are saying us to do the things are, see, they are saying that we are given with this particular cost, right? And we are required to figure out what is the lowest in a particular iteration in this number of candidates. And this number of candidates from first half and the second half. And in both of them, we are required to check what is the lowest. And that lowest would be pushed to our answer plus equals to whatever lowest is there, means L1 which is there, right? And according to that, then we will be doing K minus minus that we have done with our 1K count. So now it will become 2, right? And now this process will go on. This process will be ongoing, figuring out that which is the lowest element out of both of this first half and the second half. And according to that only, we will be moving ahead. But now comes the part that how we will be doing this. Means how at every time we are required to check that first half, second half, which is the lowest one. So in that context, we will be using min heap. So min heap, what it would be doing is that in the min heap, we will be basically choosing two min heaps, means taking two min heaps. So min heap one, which is there, so it will be choosing our first half candidates. That is the thing which this min heap would be doing here, means our first min heap, and the second min heap which is there, min heap 2, which would be there, that will be choosing our second half candidates. I'm saying second half and first half, means basically whatever full is there, and first half and the second half, means some portion might be left here as well. So that's what I'm trying to consider, and that will be surely left. That is also one of the things. Second half candidates. So this is the thing here. So this question is about priority queue. Okay. Now comes the part about that we are storing first half in this and second half in this, right? And because of this fact only, we are following this particular rule. A worker can be chosen once, and we are required to break the tie on the basis of smallest index. Because of this only, uh, because of this taking of two priority queues only, we are directly fulfilling these two conditions. So that's the thing here. Now, in choose means in making this two priority queues as well, there would be one thing. See, how we are filling up this priority queue is that maximum content which would be there is as per the candidate input. Means at max element which would be stored in our priority queue is the number of candidates only, right? So there could be some case, see 10 is there as the cost length, right? So 4 plus 4 is equal to 8, right? So this is all right. Then we chose one element. So now it becomes 9. Then again 4 plus 4 it will be equal to 8. Then also it's all right. We chose one element and then again it's good to go. But when it comes 8, so 4 plus 4. Okay, when again we chose one element. But in this context, when we will be, means say the thing is like in this 10 elements only, 4 and 4 was there, but eliminated, this 9 comes, then 8 comes, right? And when it comes the part for 7, right? So at that moment, we will be having overlapping elements. This 1, 2, 3, 4, 5, 6, 7, right? So here the elements would be this 4 and this 4. So basically this element would be common, right? So in that context only we are required to handle this particular case as well. So we are required to write our code in that manner that we are having two priority queues for handling the case of that index and choosing the workers not more than once, right? And the second thing which we are required to figure out here is that we don't count one element more than one, because of that only means this case which I'm saying, and which is directly depicting this, that we are not required to choose one element twice. So in that context only we are required to figure out that how we are required to handle this. And because we are using min heap, so as a upper bound means as overview sort of I'm saying, not upper bound but overview sort of I'm saying, that it would be L log n time complexity, and the space complexity for time being, as we figured out that priority queue would be the only one which we are taking is auxiliary space, and the maximum element would be up to candidates only, right? So here the space complexity would be the candidates, because at max we will be storing this candidates only. So that's the thing. And this n we require to figure out that what exactly this n is. This n could be, because we are required to do k number of iterations, and at max candidate number of numbers would be stored in our priority queue. So as per that only, we are having k into n, and here also k into n. N I'm saying about the number of candidates. So that's it. So this was about the intuition part for this particular question. Now it's time to code this particular question. So let us now code this question. Means how we can go ahead with the coding part for the same. So the first thing is that as there is given with that we are required to have that priority queue, right? So in that priority queue thing only, we will be moving ahead by creating two min heaps, right? And after creating those two min heaps, then the next thing which we are going to do is we are required to figure out with the how we are required to fill up those priority queues. And after filling those priority queue, we are also required to keep a check that while filling those priority queue, there is no overlapping sort of condition. So that would be the thing which we are required to do. Now, let us go ahead with the coding part for this particular question. So here, first thing is that we will be making two min heaps. And those min heaps would be like this, because we are using C++, and in C++ there is a max heap by default. So we will be making our min heap, and how we are required to make the same is by using the priority queue already available data structure, and the I would be long, and I long because here we are storing the cost, right? It could go up to that much extent, so that's why long, and then vector of long, and then making it a min heap. So this is our what we say our template for priority queue. Now we will be using two priority queue. So one priority queue would be for the left side PQL, and the other priority queue would be for the right side PQR. So this is how we made the two priority queues. Now comes the part. Let us first take the size of this so that we can easily use it again and again. So it would be cost.size, cost.size, and then we will be going ahead with start equal to 0, int equals to n minus 1, and then count, and this count will help us to eradicate the duplicate elements. So now we are going to fill priority queues from start and other one from end. So this is how we will be going ahead. So while our start is basically less than the we won't be taking n. We are required to fill candidate, right? So our, let us take it as, okay, let me increase my speed only. Yeah. So while start is basically less than candidate and our count which we are taking, that should be less than our n. Why n? Because we are required to fill the priority queue with candidate number, right? But we are maintaining that count which can go up to n. That doesn't require to be till candidate. So that's why we are doing in that manner. Now comes the part pushing up elements to the same. So to our left priority queue, we are pushing the cost which is being given to us, is cost input which is being given to us, start, that's why I don't code, start plus plus, and then int plus plus. So this is the thing which we are doing for filling up our, that priority queue which is there. Our first priority queue basically, these are left sided. Now this is for our right priority queue. So here we will be checking that while it is end greater than n minus candidates which is being given to us, and our count is basically less than n. So by keeping these things as a check, then we are required to fill our second priority queue, that is PQR dot push cost of end minus minus, because uh, we are going from end towards start. So that's why, and count plus plus. So this would be the thing. And like this manner, we are initially filling up our start means initial priority queues, which is there. That's what we are doing here. Now comes the part that after this priority queue thing, we are required to go ahead with doing all the things which is there. Means doing the thing of means checking the element which is smaller out of them, because why we are using this priority queue? We are using this priority queue so that we can figure out with the smallest element from the first half and the second half, right? So now that's the part we are going to do. So here long answer equal to 0, and we will be taking total number of elements till now, so that's why taking the total. Okay, this will be giving us the total number of iteration which has been done, so that's why total is in K. Means now we are going to go ahead with the number of iterations, so that according to that only we will be picking up the potential candidates from the starting and from the end. So that's the thing. So now let's just do long a equals to, because these things will help us to figure out with what is the minimum element. So that's why we are initializing with int max. Now, if I this priority queue which is there, if it is having something, means if its size is there, then we will be picking out the top of the whatever is there in that particular priority queue and keep that particular thing here. Dot CQR dot size top of the priority queue. So these things would be done here. Now comes the part, means now we have chosen the topmost element. That is the minimum element of both of the priority queues. Now the next thing which we require is to check that out of both of these minimum elements, which is the minimum. If our A is greater than, means our leftmost is greater, okay? So in that context, we are required to push our B into our answer. So that's the thing which we are required to do here. We will be popping that from our right priority queue. And then comes the part that because we popped one element, right? So surely there would be some more elements there, right? So we are required to push those elements to our priority queue. So that's what we are doing here. Okay. And if this condition is satisfied, we will be doing PQR dot push first and minus minus. So this would be the thing. And we all also require to increase our count, which keeps the check for our duplicates. This was for this part. But other way around, if our A is smaller, that could also be the case, right? So in that context, we'll do all things same. Just we are required to replace our here B would be replaced by A and here we will be popping out from L and then these conditions will remain same but here we are required to push into our left and here it would be pushed by start and rather than minus minus it would be plus plus. So this is thing which we will be doing in this particular portion. And after this if else condition in this while loop only we have figured out with one element till now, right? So that's why we will be increasing our total size. So we incremented that total. So after finishing up the total equals to k, means now total when becomes equal to k. So this will return and our answer will be fulfilled because of these things. And that's why we are required to return answer at the end. Okay. Yeah. So from here you can see that we are using just this auxiliary space that is the priority queue which is there and filling up the priority queue so that takes candidate time only, right? Here k time, right? And here we are filling again up to the length which is there. But we are filling as per the number of candidates only. Yes. Actually not up to the length which is there, but up to the fact that k number which is there. Okay, yeah. Here we are filling as per the candidates and here we are filling as per the k iterations. Okay. So because of that thing only, the time complexity is not that n into k, but it is into n plus k into log of n plus k. Here basically our here n is basically the number of candidates and the k is basically the k input which is given to us. So we can write directly that thing. And the space complexity is order of n only, where n is this number of candidates only. So this is about the space complexity and time complexity for the same. And let us run this question. Unknown error 8. Oh, sorry, net. I don't know. My net disconnect. That's why uh like my two live session got like anything. Okay, let us run the code. File error. Oh, 935 costs, not cost. It was unable to get the that what we say array. So that's why. So here, yes, it got accepted. So yeah, this was all for this particular question. Hope you like the explanation for the same. And as you are doing this particular contest, so you can also figure out with one more contest in the description below. So that's the contest by Newton School. About this, every detail you could figure out in that link only. And when you get into the top performer, then you will be getting the some of the most exciting prizes which would be there. So yeah, you can head over to the link and get yourself registered for free of cost. So yeah, this was all for this particular video. Hope you like the explanation. If you like it, then do like this video, subscribe to my channel, and also do share among your friends. So this was all. Thank you.